Hi, welcome back to my YouTube channel. So in this new video series, I'm going to discuss 2016 GCE A level English medium chemistry MCQ paper. Right, let's start. What is our first question? It is green light of wavelength 4.42 into 10 to the power minus 7 meters is observed in the emission spectrum of hydrogen. The energy of one photon of this green light is. Yes, they have given the wavelength and they are asking what is the energy of one photon of this light. Yes, what is the relationship between this energy and the wavelength? Yeah. Can you remember Max Planck, right? He was the scientist who proposed that the energy is quantized. That means the energy can be either released or absorbed by atoms only in discrete quantities of some minimum size. That means like energy packets, right? He gave the name quantum, right, to the smallest quantity of energy that can be emitted or absorbed as electromagnetic radiation. And he built up an equation between energy of one photon and the frequency of radiation, right? Energy of one photon is equals to the product of a certain constant and frequency of radiation. Here the constant is known as Planck constant and it is symbolized by simple h, and the value is 6.626 into 10 to the power minus 34 joules seconds. But here you see, right, we need the frequency, but in the question they have given the wavelength. So we should know a relationship between frequency and wavelength. Yes, can you remember? There is an equation like C equals mu lambda, where C is velocity of light, right? Then mu means again frequency and lambda is the wavelength, right? Then we have this equation also equals h mu, right? From this equation, right, we can subject or we can find what is mu, what is frequency, right? Okay. So E is equals to h into C over lambda. Then we can substitute the values to this equation and we can find the energy of a one photon, right? What is the value of h? It is given at the top of the paper. That is 6.626 into 10 to the power minus 34 joule seconds into C means velocity of light. 3 into 10 to the power 8 ms minus 1, right? Should be divided by the wavelength lambda, right? Wavelength it is given in meters, right? If it is given in nanometers, you have to convert into meters. But in this question, they have given it in meters, right? That is 4.42 into 10 to the power minus 7 meters, right? When you simplify this, you can get the answer as 4.5 into 10 to the power minus 19 joules, because you know energy is measured in joules. But they have given the answer in kilojoules. So we have to again divide this answer by 1000. Right? When you divide this by 1000, right, the answer should be 4.5 into 10 to the power minus 22 kilojoules. So this answer is given in the fourth one, right? So for the first question, the answer should be fourth answer.